So here we have a typical 18 carbon fatty acid, which will be broken down through beta oxidation. Each round will reduce the length of the fatty acid by 2 carbons and give us one acetyl-CoA molecule. Each round gives us one FADH2 and one NADH. For an 18 carbon fat, we require 8 rounds of beta oxidation, meaning that this will produce 8 FADH2, 8 NADH, and 9 acetyl-CoA. Now with the acetyl-CoA we have, each acetyl-CoA molecule will move through the citric acid cycle and be oxidized to CO2. With each turn of the citric acid cycle, we get 3 NADH, 1 FADH2, and 1 GTP. Due to the 9 acetyl-CoA produced from beta oxidation, the citric acid cycle happens 9 times, so in total, 27 NADH, 9 FADH2, and 9 GTP will be formed. Overall, we will have 35 NADH, 17 FADH2, and 9 GTP. Now, in the electron transport chain, 1 NADH gives us 2.5 ATP, 1 FADH2 gives us 1.5 ATP, and 1 GTP gives us 1 ATP. Let's start with NADH. 35 times 2.5 gives us 67.5 ATP from NADH. For FADH2, 17 times 1.5 gives us 25.5 ATP from FADH2. And lastly, for GTP, 9 times 1 gives us 9 ATP from GTP. So this gives us a total of 122 ATP. But we need to remove 2 ATP from our total in order to activate the fatty acid. The fat starts off in the cytosol of the cell, yet oxidation occurs in the mitochondria, so we need to move the fatty acid into the mitochondria, and this process costs us 2 ATP. Let's put all the ATP together now. The 122 ATP produced from the reducing equivalents minus the 2 from the activation of the fat equals a total of 120 ATP. A massive 120 ATP from one fatty acid that's almost as big as my biceps.